you get the following points. You get 1 point for the integral. You get 1 point for the bounds. You get 1 point for the answer. So, suppose that you got 2 of those and you had to look at your notes and you need to cut your points in half. Get what I'm saying? So if you had to look at your notes, then you get 1.5 points for this problem if you got everything right. If you didn't have to look at your notes, then you get 3. Okay? Score it. Figure out what you get. Use your best knowledge. Find the volume of R when it's revolved around the horizontal line. Y is equal to -1. I should see pi times the integral from 0 to 1.807 of g of x plus 1 quantity squared minus f of x plus 1 or minus a -1, however you write it, squared dx. Okay, that's what I want to see. And that answer comes out to be 4.029 pi or 4.030 pi or 12.660. So you get 1 point for the integral, you get 1 point for the bounds, and you get 1 point for the answer.
Can you do like R squared?
Did you come up with the right answer? So Abby, I'm trying to, so is your question, did you write here big R squared minus little r squared? So on the test, they will not accept big R squared minus little r squared. They want you to write the function rule. They want you to write g of x or f of x or put the function rule in it. So, Annika, your question was a 12.6. That's if you multiply the pi. Which part?
So like I can't write like what g of x actually is.
Yes, you can.
Okay.
Here's what you can't do. You can't say it's big R squared minus little r squared. That's not enough. They need to know what this is. G of x plus 1, or if you actually take what g of x is and put it in there, that's fine as well. Okay, so that would be a total of 3 that you could get. The bottom one, region R is the base of a solid. You should have, we've got 0 to 1.807. 1/2 times g of x minus f of x, that quantity squared, dx. And it's equal to 1.509. 1 for the integral, 1 for the bounds, and 1 for the answer. So, again, try to figure out exactly what you had to do. If you're able to do it on your own, great, you got 9 points. If you had to look at the sheet, you get 4.5. Suppose you got 6 out of 9, but you had to look at the sheet in order to do it all for you. That means you get a +3 on this. Okay? So, list at the bottom what you got out of 9. Okay? Everybody good? Can we move on to the second one? What? Problem A, V of 1/2 is equal to -0.665. That is 1 point. Part B is A of 1/2 is equal to V prime of 1/2. So you're taking the derivative, and that should be -1.018. That is worth 1 point. Is the particle slowing down or speeding up? Speeding up. And why? Because A of 1/2 and B of 1/2 are same sign. So that'll be 1 point there and 1 point there. 2 points. We're going to give you 1 point for knowing it's speeding up and 1 point for the justification. Any questions so far? Okay, part D. When does the particle change direction? You're considering V prime. I'm sorry. You're looking for v of t to change sign at time is equal to 1.701. It changes from negative to positive at time equals 1.701. If you guys see that I did something differently, if you're like, I don't think you got the right answer, let me know. I didn't go over, like I just pulled this straight out from last year, so I'm just trusting I did everything right.
What if you actually, like, I actually wrote, like, that one and another one, so then I marked it. Because I wrote 0 because I thought it was, like, crossing there.
Okay, so hold on. So you came up with 0?
No, I came up with 1.701 and 0 because I didn't know if it crossed.
And 0.
Yeah.
Okay.
Because I didn't know if it's crossing at the actual 0 point, like, counted. Because it
Got it.
Right.
And what'd you come up with?
I came up with negative 2.2.
Okay.
1.701. Negative 1.2.
Okay, just to be clear, folks, it says from 0 to 3. So we're looking for the interval from 0 to 3. So I don't care. You don't have to have 0. If you got it, great. I don't care. I want the 1.701. That's what I'm most concerned about. Find the position of the particle. Position of the particle. Negative 4 plus the integral from 0 to 3 of v of t dt. Okay? And so you should get negative 1.725. You get 2 points here. One for the integral, and then one for the answer, in case somebody plugged it in incorrectly. One for the integral, one for the answer. Total distance traveled. You need to have the integral from 1 to 2, because it's time 1 to time 2, absolute value of v of t dt. And you get 4.287 or 4.288. Either one works. 1 point. Okay. 4 point what? 539? It's 0.539? Okay, we're going to trust that that's right. So we've got 1 point for bounds, 1 point for the integral, and 1 point for the answer. Find the average velocity. I need the integral of 1 over 3 from 0 to 3 of v of t dt. And that is 0.758. And we're going to give you 1 point for the integral. So 1 point for the integral, knowing it's 1/3 integral, and then 1 point for the answer. And then find the average acceleration. I need you to have v of 3 minus v of 1 over 3 minus 1, which ends up being 3.368. And we're just giving you 1 point for that based on the answer. I count a total of 13 points there. Decide what you should get based off of how much you needed to use your notes. One point. All right. Talk in a group of 2 or 3. How are you doing so far? Tell your friends how you're doing so far. Okay, 5, 4, 3, 2, 1. Here we go. Shh. Is there a time where r prime has to be equal to 25? Let's change the question. Is there a time where r of t has to be equal to 25? Is there a time when the rate has to be 25? I'm changing the question. I'm not asking about r prime of t. Is there a time where r of t has to be 25? Why? Yeah, so if this was a 0, then would there be a time where r of t has to be 25? Yeah, so it's not asking, and what theorem states that? The intermediate value theorem states that, the IVT. So when they're asking for singular functions and their changes, that's what you go for. But notice that this is a rate function, and that's what invokes the mean value theorem. And so I'm going to look from 0 to 12, and I'm going to take 300, or actually the best way to write it would be r of 12 minus r of 0 over 12 minus 0. Or 300 minus 200 over 12. Oops, sorry, I don't know what I'm doing. 300 minus 200 over 12. And do you get 25? Do you? You don't. So let's look for another category. Is there any spot up here where you see that the rate of change is 25? How about right there? What if we would go r of 9 minus r of 5 over 9 minus 5? What is r of 9? Minus 50 divided by 4. I got 100 divided by 4, which is 25. So most of the time, they will give you intervals that match up with what they want you to choose. In this time, you had to look within the interval to see that. Looks like I caught you, huh? You can look within the interval. Now, if they ask you 2 to 5, well, then you can't go further inside the interval, can you? When they broaden it to 0 to 12, you can look inside the interval. So the answer here is yes. And it's the mean value theorem. And so you get 1 point for the answer and 1 point for the justification. I feel bad. I feel like I tricked y'all. Got it. Must there be a time from 0 to 12 when the rate at which the bacteria growing is 40? So this is like does R of t have to be equal to 40? No. It doesn't say to justify, does it? So we're just going to allow 1 point for the answer. If I did say justify, you would have to say the IBT does not guarantee, because it never drops below 50, right? It never goes down to 40. So, but I didn't put that in there. Change for next year. Estimate R prime of t. So you want to look at R prime of t over 12. So you want to look at that range. So if I'm going to estimate that rate of change, I do R of 12 minus R of 0 over 12 minus 0. R of 12 is 300 minus 200 over 12, which is 100 over 12, which is approximately what? 25 thirds, or 8.3 repeating. Okay, so that's, and then if we find a rate there, we'd be, you don't have to write the rate, but bacteria per hour squared. Okay, that's what you would want. So 1 point for the 8.33. 1 point for the 8.33. Use trapezoidal sum. Well, in order to do trapezoidal sum, here's what we want in order to get some of your results, folks. So if you set this up, I'm going to make a trapezoid. I'll do 2 trapezoids so you can get the point here, okay? What's going to be the width of this first trapezoid? 2, and what are the 2 heights? 200 and 100. And then this one's going to be a width of 3 with a height of 100 and a height of 50. So I need to see like 1/2 times 2 times then 200 plus 100. Plus, and I need 1/2 times 3 times the sum of 100 plus 50. So that's what I'm looking for the trapezoidal sum. I came up with the trapezoidal sum to be 1600. Bacteria. So we're going to go this. We're going to go 1 point for using the trapezoidal sum, and then 1 point for the answer. So if you set up a trapezoidal sum properly, give yourself a point. If you got the answer, give yourself another point. Use midpoint sum with 2 subintervals. So midpoint, I should see 5 times 100 plus 7 times 150. And that would estimate to be 1550 bacteria. So we're going to go just 1 point for the answer there. 1 point for the answer. You got 1550. And then use the right-hand sum with 4 subintervals to approximate the average rate So the average value of the rate function is 1/12 times the integral from 0 to 12 of r of t dt, which is approximately equal to, man, I had 2 times 100 plus 3 times 50 plus 4 times 150 plus 3 times 300. I got, and when I divide it by 12, I got 154.16 repeating bacteria per hour. Anybody else confirm that? 154 and 1/6? 925 over 6. 925 over 6 bacteria per hour. 185, yes. 1850 over 12. All sorts of answers. You did by hand. We're going to give 1 point if you did the right-hand sum, and then 1 point for the answer. That page, I had a total of 10 points. Out of 10. Figure out how many points you get out of 10 on that page. You were halfway done. Yes. The integral? You don't. Question.
Do you just ignore the starting amount of bacteria? Because I added mine to the end because it said like there's 500. That's like, do you just not count that?
Oh, you're right. It should be the number of bacteria accumulated. So give yourself a point there.
So it should be right?
So you should. So the question. Okay. Let me ask the question here. Okay. Huh? Okay, looks like the one we just did is 9. Sorry about that. Yep. Shh. So, we're not going to take a point off this, but Abby is entirely right. If you look at here, it says use the trapezoidal sum with 4 subintervals to approximate the accumulation of the bacteria. Yeah, right, but the accumulation of bacteria is simply the integral from 0 to 12, and you did that whole trapezoidal thing. Look at the difference here. This says use the midpoint sum to approximate the number of bacteria. That's different than the accumulation, right? So the total number is the start plus then the accumulation. Get my point? So 1,500 have accumulated, but how many are there to begin with? There's 500 to start with, and so you would add that 500 on. Now, don't take a point off because I didn't word the problem very well. I need to go back and redo that. But if you got 2,050 instead of the 1,550, that's just fine. You actually did the problem right. So, okay, flip it over. Arriving and departing, how much gravel arrives in the first 10 hours? I should see the integral from 0 to 10 of r of t dt. And you should get 22.485 yards. 1 point for the integral, and 1 point for the answer. How much gravel leaves during the first 10 hours? Integral from 0 to 10 of d of t, dt. Haha, dt. Nobody left. All right, that's equal to 20 yards. Yeah, dt, dt. There's 2 dt's. It's just kind of funny. No, it's like, it's Wednesday and it's raining and we got home at 11:45 last night. It's that kind of funny. Okay. To the nearest tenth, how much gravel is in the pit at time is equal to 7. So you have to figure out how much is at the beginning, and there's 3,700 at the beginning. Is that right? Oh, sorry, I couldn't read my handwriting. I'm getting old. Well, I gotta like hold things away now to read. It's like, what's yeah. It used to happen when you're 50. Now it happens when you're 40 because it's just there's just so much screen time. So.
Yeah.
Your eyeball.
So here's the deal. You got to do the beginning, and then you're going to add the amount that arrives, and you're going to subtract the amount that departs. That's the idea. So if you have written that in a slightly different fashion, like if you set up the two integrals, that's fine. What you should come up with, I have 3,401.618. You get 1 point for using 3,400 at the beginning. So if you knew to use 3,400 at all, you get a point. You get 1 point for the integral. So if you had r of t minus d of t and you had 0 to 7, that's a point, and you had 1 point for the answer. So figure out how many points you get there. What? Yeah, to the nearest tenth. Yep, you're fine. During the 10 hours, when is the amount of gravel at the pit increasing? So that's when the amount that's arriving is, or the rate at which it's arriving is greater than the rate at which it's departing, right? And so when is r of t minus d of t just greater than 0? So if you consider that on your calculator, you should get from 0 to 2.090, and from 548, anybody? To 10. So you get 1 point for this setup. You have to, considering those pieces, and then you have 1 point for the answer. So they are going to want you to state some type of reasoning to say, well, why are we finding those? You're looking for r of t is greater than d of t. You didn't have to necessarily subtract it over. There's multiple ways of solving this, but is the rate at which people are arriving at the gym, is the rate at which the gravel is arriving at the plant increasing or decreasing at time equals 4? R prime of 4 is negative 0.444. Okay? And so therefore it is decreasing. One point for your answer. And we are going to skip this one. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10. 10 points out of that one. Figure out what you get. Is that the one where you guys really needed to look at your notes? Because that's the next piece that we want to try tomorrow. Tomorrow we want to try arriving and departing. So. Okay, almost done here. We got 2 pages left. If it says find h prime of 1, you should recognize that you need to use the chain rule here. So I want to see f prime of x times g prime of f of x. So you got to use a chain rule. If there's something that recognizes use the chain rule, give your 1 point for using the chain rule. And then 1 point for the answer. And the answer is 1. Do you need me to go over that?
Yeah.
I got 1.
Why did I get 2 times 6?
So let's check to see. This is the function. So what is f prime of 1? What's the rate of change here? 2. So I've got 2 times, and we've got g prime of f of 1. So what is f of 1? 2. So now I'm looking for 2 times g prime of 2. I know what g is. It's this thing right here, right? So I got to figure out that derivative. Well, I've got u to the 1/2, and I've got 3x, and so I got 3 And I got 1 over 2 roots of u. Okay, so I get 3 over 2 roots of 3x. Is that right? So then if I plug in, what am I oh, 3x plus 3, excuse me. All right, what do I plug in for x? I plug in 2. What's 3 times 2? 6 plus 3, square root. Just cancel, I get a half. 2 times a half is 1. E questions, so. All right. Let's try this. K prime of negative 0.5. Looks like I need the product rule, folks. So, product rule is going to be 4 over 4x minus 2 times f of x plus the natural log of 4x minus 2 times f prime of x. So 1 point if you use the product rule, and then 1 point if you got the answer, and the deal is it's an undefined result. So if you came up with an undefined result or like a no solution or slope doesn't exist, that would be correct in that scenario. I don't think you're going to see that. I just wrote a bad problem. Okay, problem C, it says write an equation for a line. So you need your slope and you need your point. If it says that x equals 1, you plug in 1 and you should get 6. You get 1 point if you got the point correct. If you got 1, 6, you get a point. The slope, you got to use the chain rule and the product rule there. You come up with a slope of negative 42. And we got y minus 6 is negative 42 times x minus 1. So we're going to go 1 point for the negative 42. We're going to go 1 point for the slope. And we're going to go 1 point for the equation for the line. So, so those are your three points there. If our function is equal to this thing, we're trying to determine r of 5. That means we plug in 5, which basically means that what you're doing is you're trying to find the area from negative 3 all the way over to 5. And as you try to find the area from negative 3 all the way over to 5, you should get 21. Get 1 point for the answer. And then determine r prime of 3. R prime of 3 is the same thing as f of 3. And so we're going to locate f of 3. As you can see, f of 3 is simply 4. 1 point for the answer. And does r have a relative maximum over the interval? So it will if r prime, which is equal to f, changes from positive to negative at any point over that interval. Does it change from positive to negative? No. And you should say no because it never changes from positive to negative. 1 for the answer. And 1 point for a justification saying it never changes from positive to negative. I have a total of 10 points on that one. Okay, here's your slope fields. They should look something like this. Okay, slope field, something like that. We good? Okay, 1 point for the slope field. Sketch through 0, -1. So I've got 0, -1. That's that spot right there. And I should see something that looks like that. It's 1 point there. Okay, so here we got to find an equation for lines. So let's make sure that we've got, in order to write an equation for line, you need two things. What do you need? Slope and a point. So your point in this scenario is what? 0, 3, right? And your slope, you simply plug in 0, 3 into your differential, and you should get -1. So that means your equation for your line is y equals -x plus 3. You get 1 point for the equation for the line. And then when you want to do the approximation, your approximation, so we would say that, and this is the proper notation, I didn't use this before, but please pay attention, f of 0.2 is approximately equal to, and what we do is we plug in a 0.2, right? So -0.2 plus 3, which is 2.8. So 2.8 is your approximation. And our last part. All right, it's time to separate variables, isn't it? So you should have dy over y is equal to 2x dx. So you get 1 point for the separation of variables there. If you had 1 over y, that's fine as well. Then take your antiderivative. Natural log of the absolute value of y is equal to x squared plus c. 1 point if you found the antiderivatives correctly. I won't mark it wrong, but they will not give you the credit if you don't put the absolute value of y in there. Okay. To solve, we raise both sides to e, or as a base of e, and so you come up with y is equal to some constant times then e to the x squared. So 1 point for the general solution. So having a general solution, there's multiple ways of representing this. If you left the plus c up in the exponent, that's technically correct as well. We've been over why the c goes out front, right? Which was never, like, I didn't know. Like, first time I saw that, I was helping somebody who came home from college. They're like, can you help me with my Calc 2? And they were trying, like, how did the c just go out there? You know what I mean? I've never seen it before. But you guys are smart. You're smarter than me. Look at that, okay? Way to go. You're like, that's no big deal. And then I find the condition, you should get c is equal to 3. And so you should get then y is equal to 3 e to the x squared. And so that would be another point. That's a total of 8 on that page. Decide how many you should get. Yeah? So what do we got for points? 32, 42. What do we got for total points out of this whole thing?
It's a 55. I got it. What is it? The complete thing. I got that. Girl, no, you didn't. Are you like 9?
So I had 62 for me, but that was, we had gotten rid of a couple problems. What do we have? 59? Okay. So here's what I want. I want a total out of 59. Please put it on top.
I thought I actually did.
Okay, so go ahead and put your score at the top. Okay, so remember that like an A in class would be like, say 54 out of 59. So if you got a 54 or 59, that's better than an A, okay? I don't expect that people are going to have that type of score, okay? So this is to give me an idea of where you're at. I have a little scale so I can see how people are doing. I would say if you got more than 50%, you're doing well, okay? Good job. Now, here's what I need to know from you. I need you to look at the 6 problems. So first of all, does everybody have a score up there? I want a score. Is your name on it? Okay. All right, here's the 2 other names I want before we leave class today. I want to know your best and your worst. And we're going to do this as a class. I want you to pick numbers 1, 2, 3, 4, 5, or 6. Which of those 6 you're like, you know what? That's my best section. Like, those are the ones I feel best. Quick, 30 seconds, talk to a partner. Which of these 2 are you like, you know what? If I saw those on the test, I'd be like, I'm rock solid. Like, I own these, okay? Go, talk. The sections, we had 6 sections. You have to choose 2. We'll start with the best, then we'll go to the worst. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Stop. Okay. The first section was area and volume, right? Raise your hand if area and volume is your top. One of your top 2. We got 1, 2 people, 3. Okay. Second one was what? Motion, velocity. Raise your hand if that one was yours. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Raise your hand if so. The third one, that was the one where you had the table, Riemann sum, stuff like that. Anybody have a table problem? 2, 3. Problem 4, that was the arriving and departing. 1, 2, 3, 4, 5. Section 5, that was like the free-for-all, like just try some derivatives with graphs type thing. And it's funny because like when I first looked at all these before like really teaching prepared for the AP, I was like, oh, that'll be people's favorite because that's like closest to some of the stuff that we've done. But they're challenging problems. I get it. And then slope field. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We'll go with 13 there. Okay. Talk to your partners. Which are your 2 like least favorite? Like if you saw those on a test they gave you, you'd be like, shoot, he picked those 2. I mean, yesterday we went over, which one did we do yesterday? We went over the table type ones. Okay, and stop. All right, worst ones, area and volume. That makes my heart hurt. I love those ones. All right, motion, velocity, table problem. That's what we went over kind of yesterday. 1, 2, 3, 4, 5. Arriving and departing. Free for all.
The easy one.
No, like no. I just like it's just one of those. I'll show you guys here in a second. You guys will be floored by this, and it's just the reality. It's how much teachers just really don't know sometimes, and you just are shocked. So we got problem number 6. So that was the slope field and the differential equation. Anybody? 1, 2. Okay, 2. All right. Well, so obviously I know where to concentrate some of my work, and I know the things that we should be doing well with. But good job overall. My question to you is, so a fist of 5. So a 5 being like I really could do most of this without using my notes, and a 1 being like I pretty much had to look at my notes, most of the time. You know what I mean? Where are you at? Show me fist of 5 so I can see. 5 was. Right. Okay, all right, so I'm almost there. Okay, I'm gathering, I see where we're at. This is helpful to me. So my next question is this. I'm assuming that our process by where, like, so tomorrow I would give you two free response question problems like we did the other day, and you work on them together for like 11 minutes, which, by the way, I've been giving you 11. You get 15 on the AP exam, but we just don't have time to do the 15. But that you would try it, we go over it, and they get to try a second one. Like, that's helpful to get a frame of reference so you actually have an idea of what you're doing. Are you guys able to start classifying these in these groups of 6 a little bit? Do you know what I mean? Like, I get it. Like, I can see a problem. I'm like, oh, that's that type of problem. Go there. But I've done them for so many years. I want you guys to be able to begin a process where you can start to classify. What does this look familiar to? Are you developing familiarity a little bit? Little bit. Okay? Okay, all right. Okay, so I'll end with this here. This was great for me. So this was pre-calc. So you guys remember how we did like a proficiency test in here to see like what we remembered throughout the year. So we'll go back and we'll modify that. We'll try it again, and you guys will do better, obviously. To kind of see where you're at. But so I want you to look at these problems, okay? And I want you to look at one where you're like, oh, that one is one that like I bet that was the lowest scoring problem. So here you got like exponents, factoring, a complex fraction, solving equation by multiplying through by something. Here you got a quadratic inequality, equation for a circle, write an equation for a line, domain and a graph of something, put something into vertex form by completing the square. Yeah. Composition of functions, finding an inverse of a function, graphing a polynomial by finding all the roots doing synthetic division, logarithms writing as 1, solving an exponential, and then we've got exact values of sine using the unit circle, SOHCAHTOA, graphing sine or cosine, simplifying a tangent over sine expression, and solving an equation. Is there one that you're like, you know what, that one that would be painful, like that section, like I don't remember that part at all. Second page. So you're like, okay, so this guy right here, so like composition, inverses, polynomials, logarithms. So no, so this was a lot of this was second quarter for you guys last year, okay? Yeah, exactly. No, you guys, your recall is totally compromised from last year. You guys have done a great job. You've been very, very impressive to me for how much time we spent away. Do you know what the number one problem that people got wrong was? Out of the group, only one problem got this one right. Find an equation for a line that's perpendicular that passes through 6-1. If it's perpendicular, the slope's the opposite reciprocal, pass through the point, go to work. And isn't it incredible? Here's what's remarkable about that. Like, that's been taught since 7th grade. And yet, our best of the best, like, we forget it. And so that's just where it's like, holy cow, I can't believe. But that's the reality. We forget. So good job. I'm going to take these from you.